This is Dr. G. Ravindranath Reddy, working as Assistant Professor of Mathematics in MLR Institute of Technology, Hyderabad. As we know that we are discussing the numerical methods and integral transforms. So in this, we are discussing how to find out the Laplace transform for the function t into f of t and f of t by t. So in the previous video, we have seen how to find out the Laplace transform of f dash of t and Laplace transform of integrals. Now in this video, we are going to find out the Laplace transform whenever that function f of t is multiplied with t and whenever the function f of t is divided with t. So here we will get Laplace transform of t into f of t. So we are going to use the formula here, and Laplace transform of f of t by t. So whenever we are having a function of this type, so we are going to get the formula how to apply the Laplace transform for this. So these 2 points we are going to discuss in this video. So first we will concentrate on the t into f of t, how to find out the Laplace transform of t into f of t. So first we will take the statement of this. So as we know that this is a common statement for this in the Laplace transform. Laplace transform of f of t is equal to f bar of s. And then if f of t is multiplied with only t, that is t into f of t, then the Laplace transform is given by minus d by ds of f bar of s, that is minus of derivative of f bar of s. Whatever the value we get for the derivative of f bar of s, you multiply with minus, then we can get our Laplace transform of t into f of t here. So this can be written as minus f bar dash of s. So f bar dash of s is nothing but derivative of this function with respect to s. And similarly, suppose if you have the Laplace transform of t square into f of t. So if f of t is multiplied with the t square, so here f of t is multiplied with only t. So now suppose if f of t is multiplied with the t square, and then if you want to find out the Laplace transform for this function, then what is the formula we will have to take? So that is given by, so since here we are having only t multiplied with f of t, so only the power of t is 1. So because we have applied only the first derivative, so whenever the power of t is 2, then we have to apply 2 times derivative here, and this minus becomes, so if you take minus 1 whole square, then you will get 1. So in general we can consider this one as minus 1. So here the power of t is 1, so we can take minus 1 whole to the power of 1 into d by ds of f bar of s. And here this can be written as minus 1 whole square. Why I am taking this whole square here? Because the power of t is 2 here. So minus 1 whole square into, we have to go for the 2 times derivative here. So d square by ds square of f bar of s. So this can be written as minus 1 whole square, that is plus, so this second derivative, 2 times derivative, that can be written as f bar double dash of s. So once if you get 2 times derivative of f bar of s, then we can get the value for Laplace transform of t square into f of t. So now by generalizing this first formula and second formula, we are going to get the Laplace transform of t power n into f of t. So here this can be written as, in general, so here we are having, whenever the power of t is 2, we have taken minus 1 whole square. Now we are taking the formula for t power n into f of t. So minus 1, and the power of t is n, so we consider minus 1 whole to the power of n. And here the power of t is 2, so we have applied the 2 times derivative. Here here we are having the power of t is 1, so we have applied 1 time derivative. Whenever we are having t square, we have applied 2 times derivative. So suppose if we get t cube, we have to apply 3 times derivative here. But here we are having the power of t is n, So for this we have to apply n times derivative for f bar of s, that is d power n by ds power n into f bar of s, n times derivative here. So from these two formulas we can generalize and we will get the general formula for Laplace transform of t power n into f of t is given by minus 1 whole to the power of n into nth derivative of f bar of s with respect to s. So this is the formula for t into f of t Laplace transform and Laplace transform of t square into f of t, and by using this we can find out the Laplace transform of t cube into f of t also by using this general formula. Now we will take the problems when we can apply this t into f of t. So if you want to apply this Laplace transform of t into f of t, the function must be multiplied with t. Then directly we can go for the Laplace transform of t into f of t here. Now let us take the problem here. So here Laplace transform of t into e power 2t into sine 3t. Forget about the exponential function. So you consider this one is Laplace transform of t. So here we are having t, so you take t here, and whatever the remaining function here we are having, you represent that function, remaining function, as f of t. So this is of the form t into f of t. So in the given function, if you find t as a multiplication of other function, then we can use this standard formula t into f of t here. Now by comparing this, you will get f of t is equal to, what is the remaining? Now neglect this f of t value here. Now you neglect this t term and you consider the remaining function as f of t. So you will get e power 2t into sine 3t. So like this, we have to compare the given problem function with the standard function t into f of t. From that, we have to get the value of f of t here. So now our task is we have to find out the f bar of s here. So that is Laplace transform of f of t. So that is Laplace transform of e power 2t into sine 3t. Now if you want to evaluate this, this is of the form Laplace transform of e power at into f of t. So in order to get this Laplace transform value, we have to take the help of other property of Laplace transform, that is first shifting theorem. So by using this first shifting theorem, we will get this f bar of s value here. So for that, first you find out the Laplace transform of sine 3t. So we have the formula Laplace transform of, this is of the form Laplace transform of sine at. So this can be written as a by s square plus a square. Now you represent this, compare this with sine 3t. Here you will get a is equal to 3. So 3 by s square plus 3 square, that is 9. Now take the formula Laplace transform of e power at into sine 3t. So how can you get this value? Take the help of this. Take the help of this Laplace transform of e power at into f of t, that is the first shifting theorem. So by using this first shifting theorem, if you want to find out the Laplace transform of e power at into f of t, the first shifting theorem says that first find out the Laplace transform of f of t. After finding this Laplace transform of f of t, then whatever the value we get for the Laplace transform of f of t, in that value replace s with s minus a. Okay, so now here Laplace transform of e power 2t into sine 3t. Now according to this first shifting theorem, we can take Laplace transform of sine 3t, find out that, and replace s with s minus. So here why we are taking minus sign here? Because the power of that exponential function is positive. So whenever the power of that exponential function is positive, then we have to keep minus sign here. Now compare this, and in place of a, here we are having 2. So replace s with s minus 2. So already we got Laplace transform of sine 3t is equal to 3 by s square plus 9. In that replace s with s minus 2. So you will get 3 by s minus 2 whole square plus 9. Now this is the value we got, Laplace transform of e power 2t into, you consider this value as f bar of s. Now we got f bar of s. Now we are ready to apply Laplace transform of t into sin t. Laplace transform of t into f of t. Now simplify this. S minus 2 whole square, you will get 3 by s square minus 4s plus 13. So this we can consider this is f bar of s. Now you take the total function. So our total function is, this is of the form Laplace transform of t into f of t. So we got this value, you consider this as f bar of s. So since the power of t is 1, so here we'll keep minus sign, d by ds. So the power of s is 1, so we have to apply only one time derivative for f bar of s. So what is our f bar of s here? This is our f bar of s. So minus 1 into d by ds of f bar of s. Now apply the derivative for this. So how can you find out the derivative here? So take this minus sign, 3 constant term outside, so you will get minus 3. So d by ds of, you bring this denominator to the numerator, you will get s square minus 4s plus 13 whole to the power of minus 1. So this is equal to minus 3. You apply the derivative of x power n formula, so you will get minus 1 into s square minus 4s plus 13 minus 1 into, and once again you apply the derivative of this base, d by ds of s square minus 4s plus 13. So you will get minus of minus plus 3 into s square minus 4s plus 13 whole to the power of minus 2 into, now find out the derivative of this, you will get 2s minus 4. So finally you will get 3 of 2s minus 4. By bring this negative power to the denominator, you will get s square minus 4s plus 13 whole square. This is the value we get here. So we can take 2 common here, you will get 6 into s minus 2 by s square minus 4s plus 13 whole square. So this is the way how we can apply this t into f of t Laplace transform value. Now we'll take one more example here. So this is how to find out the Laplace transform of t into cos at plus b. So now this cos function is multiplied with t. So when you compare this is of the form Laplace transform of t into f of t. Here also we have to apply the same formula. So now by comparing this, we have f of t is equal to, we can consider f of t is equal to cos of at plus b. Now here find out f bar of s. F bar of s is equal to Laplace transform of f of t. So Laplace transform of cos at. So that is the thing here. Cos of at plus b, this is of the form cos of a plus b. So you take cos a cos b minus sin a sin b. Apply this. So cos b is a constant, so we can take that cos b. So apply the linearity property of Laplace transform, that is linear Laplace transform of first term minus Laplace transform of second term, that is the linearity property. So in the first term you are having cos b, so we have to consider this as a constant because we don't have that t variable in that function. So cos b into Laplace transform of cos at minus, apply the Laplace transform for the second term. So in that second term we are having the factor as sin b, so that sin b becomes a constant here because no variable is involved in that function. So sin b into Laplace transform of sin at. So we have the standard formula, cos b into Laplace transform of cos at, this can be written as s by s square plus a square minus sin b into Laplace transform of sin at, we have the formula a by s square plus a square. Now simplify this. So you will get s into cos b by s square plus a square minus a into sin b by s square plus a square. Okay, now you consider this as f bar of s value here. Now we got f bar of s value. This entire value is f bar of s. Now we are going to apply the formula Laplace transform of t cos of a t plus b. Now for this we are going to apply the formula of Laplace transform of t into f of t formula. So this can be written as minus 1 d by ds of f bar of s. So what is our f bar of s? This is our f bar of s. So now find out this derivative here. So cos b, apply the derivative separately for each term. So then you will get derivative of s by s square plus a square. S by s square plus a square, you apply the derivative of u by v formula. So you will get v into derivative of u minus, you know the formula. So use that formula, v into u dash minus u into v dash by v square. Apply that formula and simplify this. In both cases, both terms you apply. So here we no need to apply this u by v formula here in the second term, because in the numerator we don't have in terms of s. So entire numerator is a constant here. Entire numerator is a constant. So we bring this denominator to the numerator and apply derivative of x power n formula here. So finally you will get this value here. So this is the way how we can apply this, when we can apply this t into f of t, Laplace transform of t into f of t formula here. So by default, whenever we want to apply the Laplace transform of t into f of t, in the Laplace transform, t must be multiplied with some other function. That some other function we have to consider as f of t. So inside the Laplace transform, if you find t into something, then we can go for the Laplace transform of t into f of t formula. Now we will go for the next concept, that is how to find out the Laplace transform if the function is in the form of f of t by t, that is t is in the denominator. In the previous we have seen t is multiplication of f of t, and here the t is in the denominator of f of t, divisible by t. So here 1 by f of t into f 1 by t into f of t Laplace transform is given by, so there we have applied the derivative whenever the t is in the numerator. Now if the t is in the denominator of f of t, then instead of derivative here we have to apply the integration. So in the denominator the power of t is 1, so one time we have to apply the integration between s to infinity, and similarly if you have 1 by t square into f of t, then for this if you want to apply the Laplace transform we have to, so since the power of t is 2, so here you have to apply 2 times integration for the function. So integral s to infinity f bar of s, so integration with respect to s both times. So this is the, whenever we are having f of t by t square, we have to apply 2 times derivative for 2 times integration for f bar of s with respect to s. So e0 to s. So here 2 times s to infinity f bar of s into ds, that is 2 times derivative here. So now let us take a problem here, Laplace transform of 1 minus cos a t by t. So whenever we find t in the denominator of that function, then directly we can go for the Laplace transform of f of t by t and then apply the integration. Use this formula, we can get our Laplace transform of the given function. So you compare this and get the f of t value and then find out that Laplace transform of that f of t. So our f of t here, f of t is equal to, so 1 minus cos at, then apply f bar of s is equal to, if you want f bar of s, we have to apply the Laplace transform of f of t, that is Laplace transform of 1 minus Laplace transform of cos at. So that can be written as Laplace transform of 1 can be written as 1 by s, and Laplace transform of cos at is equal to s by s square plus a square. So this is our f bar of s. Now take the entire function here and apply the Laplace transform. So this entire function is in the form of Laplace transform of f of t by t, that can be written as integral s to infinity f bar of s into ds. So our f bar of s is, this is our f bar of s. So replace that f bar of s with this 1 by s into s by s square plus a square ds. Now apply the integration. So integral of 1 by s, this is of the form integral of 1 by x dx is equal to log x. Use this, you will get integral of 1 by s is equal to log s minus integral of, next we will see how to evaluate this integral, s by s square plus a square ds. So now in order to evaluate this, I want to multiply the numerator and denominator with 2. So you will get 1 by 2 into integral 2 s by s square plus a square. So this is of the form 1 by 2 into integral f dash x by f of x. Integral of f dash x by f of x, we can take this value is equal to 1 by 2 into log f of x. Now use this formula. Our f of x is s square plus a square, so 1 by 2 into log of s square plus a square, and then substitute the limits s to infinity here. So before substituting that, I want to convert this is of the form log a minus log b. So you convert that. So here you will get 1 by 2 into, take the LCM, you take 1 by 2 common here, you will get 2 into log s minus log of s square plus a square. So this can be written as 2 into, suppose if you have 2 into log x, this can be written as log x square. So from these two terms I want to take 1 by 2 common here. So I have taken 1 by 2, so we don't have denominator here. So this 2 by 2. So one denominator 2 taken outside, and the numerator 2 can be written as 2 into log s minus log of s square plus a square. So this is of the form log a minus log b. So this can be written as log a by b. Now integrate this, you will get 1 by 2 into log of s square plus a square whole square. Now if you replace this upper limit as it is here, we can't define this function here. So from this I want to take s square common in the numerator. S square common, s square gets cancelled, you will get 1 by 1 plus a square by s square. So when s is equal to infinity, that infinity 1 by s can be written as 0. So because of this reason, I want to bring this s in the denominator here, and then substitute this upper limit and lower limit here. So s square, if you substitute s, if you replace s with infinity, you will get 1 by infinity, that is equal to 0. So this entire term becomes equal to 0 when we substitute this upper limit here. So 1 by 1, the remaining one is 1 by 1, 1. So you will get log 1 minus, replace the lower limit s as it is, you will get the same function as it is. So and we know that this log 1 is equal to 0. So when we take log 1 is equal to 0, the remaining function you will get, so minus 1 by 2. So you take this minus outside, 1 by 2 into log of this. So you send this minus 1 by 2 to this power of this, you will get log of root over. So since we are having a negative power, you reciprocal this, you will get s square plus a square by s square. and the power is 1 by 2, so we can remove that power 1 by 2 and we can convert that power 1 by 2 to the square root. So this is our final value here. And similarly, let us take one more example. E power minus at into minus e power minus bt by t. This is of the form Laplace transform of f of t by t. And here also you find out the Laplace transform of f of t and then apply the integral s to infinity with respect to s. So our f of t, so this is a standard formula. So this is our f of t. Find out the Laplace transform for this. You consider this as f bar of s. And then find out the integral between s to infinity with respect to s. So here also you will get this same thing. Log s minus 1 by 2. Apply the same procedure. Integral of f dash x by f of x. You will get this. So then substitute the upper limit and lower limit. You convert this in the form of log of a by b. And then substitute the upper limit and lower limit here. You will get our required value here. This is our final answer. So log of square root of s square plus a square by s square. So this is the way how we can use this f of Laplace transform of f of t by t formula. So by blind we can say that whenever we are having the denominator as t, then if you want to find out the Laplace transform for this function, then directly we can use Laplace transform of f of t by t. So here we have discussed how to find out the Laplace transform of t into f of t and the Laplace transform of f of t by t in this video. And now in the next video we have some applications of Laplace transform. Then that application is how to evaluate the integrals using the definition of Laplace transform. So this we are going to discuss in the next video. Thank you.